Hello, ladies and gentlemen. Welcome back again to another discussion on circular motion. We have been on this circular motion before. We said circular motion is also called rotational motion, and it can also be regarded as a rotary motion. It's the kind of motion that occurs when an object rotates at a fixed point about its own axis. Example of such motion are motion of a wheel of a car, a movement of a ceiling fan, and also the motion of a standing fan. They are clear examples of a rotary or circular or rotational motion. Okay, under this circular motion, we discussed something on this aspect before. We mentioned two forces. We mentioned two forces. We said centripetal force and centrifugal force. We say one is inward force, while the other one is outward force, and one keep the body along, and the other one keep the body away. Now, the one of the centripetal force is the simply regarded as the inward force, and it keep the body along the circular path, while the other one, which is centrifugal force, is known as the outward force, and it keep the body away from the circular part. Okay, but we're not looking at the centrifugal force, we're not looking at that. We are simply looking at centripetal force. We are simply looking at centripetal force and the force that provide it and the force that provide it. Please don't forget the force that provides centripetal force is simply called tension force. It means that tension force is a force that provides centripetal force. Okay. Now, I want to consider a case of a rope. That from what we have here, we are looking at tension and centripetal force. We want to consider a case of a rope. Let me say you have a rope and a ball is attached to it at one end, and you weld it in a vertical circle. You weld it round. Now, how do you weld? How do you weld? Let's see. How do you weld? Meaning you have a rope. You are having a rope in your hand. You are having a rope in your hand like this, and you decide to put your hand here. This is where you place your hand. This is you. This is where you place your hand. This is you. Okay, and you decide to tie a ball at one end. Decide to tie a ball at one end. I will attach the ball at one end. What happens? You hold it. Please let me. This is you, and you place your hand like this, and you decide to weld. How do you weld? How do you weld? Welding meaning these are to weld. These are to weld. You weld like this. How do you weld? Let me tell you how you weld. You weld like this. This are to weld. When you hold the of this end here and you attach this ball here and you weld. This is how to weld. Even those days when we were children, we normally do all these things when we were playing. We normally do it. We just have a rope, tie an object at the other end, for example, like a stool. We simply take the rope and keep throwing it like this. Meaning, as you are throwing it like this ball will maintain. We are looking at the case of the ball. It will maintain a circular path, and there is a force that will keep this ball along this path, and that force is known as centripetal force. And what provides that centripetal force is simply tension, and that tension exists in the rope. That tension exists inside this rope, and that is T. It exists there, meaning I said earlier that at this ball, as well, it will maintain a circular path in this manner. It will maintain a circular path in this manner. This is how it will move. This is how it will move in a circular manner. This is how it will move. You can see. This is the way the circle will move. It will move round. And the force that will keep this body along it is known as centripetal force. And the force that provides this force, this centripetal force, is known as tension force, and is directed towards the center of rotation. The same thing with the acceleration is also directed towards the center of rotation. Okay, now you can see what we have here. This is a clear example, meaning having a rope in your hand, attaching a ball at the other end, and you wear round. You wear round like this. It will maintain this ball will maintain a circular path. So let me take this one again. Let me take that circle again. Let me take it round. This is the circle. This is the circle. Okay, this is one is the circle. Please don't forget. And this is where you hold the rope and you attach the rope ball at one end of it, and decide to wear this, wear it. And at the end, what happens? This ball will definitely leave here and come to this position, and to leave here again and come to this position, and to leave here again and come to this position. means that we are going to have the middle, we have the middle here, we have the middle, we have the top, and we have the bottom. We have the bottom. When we consider the force at this middle, like the tension force, you don't forget I said this force that provide this centripetal force, not tension force. Okay, then look at the centripetal force or the tension force at the middle, at the top, at the bottom. Okay, this one, and this, they are both at the middle. Meaning the force that will be here will also be the force here. Okay, please take note of that. Then we want to consider this very one now. When we look at the force that will be at this point, and at this point. Please want to consider that one as we progress this course of teaching. Please let us just look at it one after the other. Now, at the middle, let us consider the one at the middle. Okay, let us now consider the tension force at the middle. Remember, I told you that we look at the one at the middle, tension force here, here, and here. Okay, let us look at the middle first, tension force at the middle. Now, remember, I told you that the force that provides centripetal force is not tension. It simply exists in the roof. Okay, it exists inside this roof. Now, let us now see the acceleration here is directed towards the center, both the tension and the acceleration. And also for this one, there's a weight force, directed downwards. The weight force is directed downward. Now, in this one, we are going to consider a component. We are going to consider a component here. Component meaning before we look at that, please don't forget our centripetal force. There is always the magnitude of that centripetal force. We always have the magnitude. Please don't forget that our sigma F, which is the net force, is equal what? MA, and our centripetal force, which is which is FC, centripetal force, which is the FC, is simply equal mv squared over r. Please don't forget, is equal mv squared over r. It means that when you have A, it's known as what? Centripetal acceleration. And when you replace this centripetal acceleration, you have this very one here. You have this one. I can also say my tension can also be what? Mv squared over r. Remember, I told you that what provides centripetal force is not tension. Please take note of that. Take note of that. Now, we want to consider this one in two components. Component of this system now, this body now. We are looking at the y component, which is sigma Fy, and the force there is downward, which is minus W. Okay, now for this one now, here become minus mg, please take note, okay, minus mg. Okay, for this one here, it means that the force is not moving vertical, it's not this, sorry, this body is not going to move vertical, it's not moving vertical, this body will rotate, it's going to rotate horizontally, meaning this body is horizontal. You can see now the rope is horizontal. It means that now, see the rope is horizontal, it means that the sum of the forces there is zero. Please take note, the sum of the forces there is what? Zero, and therefore our weight now, we can see is equal mg and is equal zero. Please take note, is equal zero. Mean there is no weight force here, mean that the weight force here is mg equals zero. Okay, now that's for the one of the y component. Let's look at s component, and the only force there on the s component is tension and it's negative. But if there's negative, please don't forget this one. This one is positive y, negative y. This one is s, positive s, negative s. You can see the direction. The direction is to this side, and therefore it's negative. Okay, the only force there is tension. Therefore, I cannot say now. From what I have here, I can see that since the body is moving horizontally, because we can look at the rope now is horizontal, therefore I cannot see now that the sum of the forces here, which is the net force, become minus okay, because the acceleration is also negative. Look at it, the acceleration is also negative, minus ma equal minus t. You take note. And when you have your a, please don't forget, I said it's the centripetal acceleration. Don't forget, and v square over r. V square over r. Therefore, this one now become mv square over r. Please take note. Okay, here is minus t. Negative can go. That is, I can kill this one. I can go. What will be left? I will be left with t equal mv square over r. Therefore, this one becomes the tension force. or the force at the middle. Please take note, this one becomes the force at the middle. Please take note of that, very, very important. That one becomes the force at the middle. It means that the force at the middle now is now known as T equal mv squared. Please take note of that. Is now equal what? Mv squared. Please take note of that. Okay. Now looking at the other one now, let's see. It means that at this point now, it means that at this point, we are going to fix it now. Let us fix it. Meaning at this point here, yeah, you see at this point here, my force here, that is at the middle, is now equal to mv squared over r. It means that this one is when the body is moving very fast, when the body or the ball, when the ball is moving, when the ball is moving, moving very fast, moving very fast. That is when the ball is moving very fast, the form of T equal mv squared over r. Therefore, this is the force here. However, if the force is now moving very slow, what will be the tension force at this point as well? What will be the tension force? Let us consider that one now. Let me now consider that one. If now let me consider the case whereby the ball is moving very slow, what will be the tension force at that middle? We are still on this tension force at the middle. Okay, let us see what will be the tension force if the ball moves very slow. Okay, now let us now see if the body now decide to move very slow. So when the ball moves very slow, it means that at the center the rope is not going to be exactly horizontal, and it is going to be at a slight angle, and so the tension force will shift a little. Let us see what will happen. The tension force will shift a little. Let us see what will happen. Okay, let us see what will happen. Okay, you can see now that the ball still remain at the middle. Look at it, the ball still remain at the middle. You can see it here. The ball still remain at the middle, and the rope only shifts. The rope just shifts a little. Look at it. So when the ball moves very slow, it means that at the center, the rope is not going to be exactly horizontal, as we are seeing there. It's not going to be exactly horizontal, and it is going to be at a slight angle. And of course, you are seeing it here. You can see the ball still remains, but the rope only just shifts a little at a slight angle. Meaning that this is the angle to form an angle here, to form an angle here. This is going to form the angle. Okay, here will be TS, here will be TS, while here will be TY. Here will be TY. It means that it means that at this point here, we are at the force here, we are going to determine the force at this middle here. At this middle, then look at the force that will be at this middle. Remember, the tension is the force that provides that force. Please don't forget. Meaning when the ball is moving slow, when the ball is moving very slow. Now, therefore, can I use Pythagoras theory? We can use Pythagoras theory in this case. We can use Pythagoras theory. This one will be Ty, and this one is positive, and this one is okay. You can see it here, Ts. Okay, you can see it here. Now, in this very one, we use Pythagoras theory. Remember what Pythagoras theory states? It means the square of the hypotenuse is equal the sum of the square on the other two sides. And the other two sides are Ts, and also the other one is Ty square. You can see now to find your T, find the square root of both sides, become what? Ts square plus Ty square. Please take note of this. This is what we are going to have here. Meaning that in this case now, what is the Ts? Meaning what is the Ts provides the centripetal force. Please take note. The Ts provides the centripetal force. And what the centripetal force we are determining is mv square over r. It means that at this point, I will say my Ts, which provides the centripetal force, become mv square over r. Remember there is a square. Remember there is a square plus, okay, what is the Ty? The Ty support the weight force. Please, this one here will not be zero. Remember here, when I determine this one, we say the weight force. Remember I determined it, we said the weight force was equal to 0. Please take note. I did this one before. We said the weight force was equal to 0, and that resulted to this very one here. Now, but for this one, the weight force will not be 0. And what supports it is the Ty. The the Ty that supports this weight force. Therefore, here become what mg square. Here become what mg square. Okay, it means that now at the middle, when the ball is moving very slow, it means that our force, the force at this point is going to be, look at it here, become this. It means that the force in that point is going to be T equal the root, the square root of mv square over r, mv square over r, square it again, plus mg, plus mg, plus mg square. Please take note, at the middle, this is the force. This at the middle, this one is the force. When the ball moves very slow, but when the ball moves very fast, you use this very one. Please consider these two formula. We are going to use it in our subsequent teaching as the discussion progresses. Okay, thank you. And now let's now look at the ball now at the top. We want to look at the ball at the top. Now it was at the middle, moving very fast, and we said T is equal mv square over r. And when the ball was moving very slow, we said it is simply this very one. Simply this very one. Let's now consider a case whereby the ball now is not at the top. Let us look at the tension force that it will be at that top. Okay, let us now consider the tension force at the top. Let us now consider the tension force at the top. Remember, I told you that this tension force is always directed towards the center. Please don't forget center of rotation. Therefore, this tension force will be directed towards the center. And also, the centripetal acceleration will also be directed towards the center as well. Please don't forget, both of them are inward. They are inward. They are inward. Okay. Now, I want to consider when the body was here, the force that will provide the centripetal force. Meaning, what the force is simply the tension. What will be the tension at this point? Now, to do that, please don't forget that the weight force as well here, the weight force here is also directed. Please, the weight force here is also directed downward. The weight force is also directed downward. Like the weight force is also directed downward. You can see it's also directed downward. Now, to determine that there is no net force on the x-axis, we only have y-axis here. Y-axis, please don't forget, we only have y-axis. Therefore, we are going to have the t there is negative and the w. The only force there is t and w is also negative. Now, in this case, let's look at the net force is ma, and the acceleration there is centripetal acceleration. This one is what? M minus T, mg. This one we call mg. That is the weight force. Okay. Now for here, for this one now, for this very one, the centripetal acceleration, look at it directed downward. Therefore, here now become minus mv squared over r. Please don't forget, this one become minus t minus g. Now making t the subject, take it over. Therefore, we're going to have our t equal, okay, we're going to have our t, when it's cross to this side, become positive, this one will move, become mv squared over r minus mv squared over r minus, okay, minus mg, minus mg, minus mg. This one becomes the formula when there is tension force at the top. There is this tension force at the top. That is going to be what? Mv squared over r minus mg. Please take note, this one becomes the tension force at the top. Okay, now look at the situation whereby the body now is not at the bottom. Remember, we are becoming middle, whether here or here. It simply means that the body is at the middle. Then now look at the bottom. Now, we are not going to consider here because we already considered before. There, when the body will move fast and when the body will move slowly, the same thing as to the other hand here. It means the same thing when the ball is also here. Okay, now consider a situation whereby this ball is at the bottom. We'll now look at the tension force that it will be at that bottom. Okay, let us see. We are going to consider that now. Okay, let us now look at the situation whereby the ball now is not at the bottom. The ball is not at the bottom. Remember, I told you that tension is always inward, it's directed towards the center of rotation. This one is T. And don't forget also the acceleration is also directed towards the center. The acceleration is also directed towards the center. Please don't forget that the tension is directed up and the acceleration is also directed up. While the weight now, the weight force is downward, please don't forget, it's downward here. This one is W. The weight force is downward. Please don't forget that. Now we have to now look at the net force now, and the only net force here is sigma Fy, that is the vertical component. Okay, now to do this now, what are we going to do? We mean that the only force there is T and W, and the T there is positive, the T there is positive, and W is negative. Now in this case, what is our sigma Fy is Ma. Please don't forget it's Ma, that is the net force. And don't forget our A is centripetal acceleration, and the centripetal acceleration is V square over R. Please don't forget. And the centripetal acceleration is positive. Look at it, it is positive. It's positive. Therefore, this one remains mv square over r. Okay, this one remains mv square over r. Okay, now equal t minus mg. Please don't forget that. Now, to make t the subject, I will carry mg over. If I carry mg over, therefore I will have my t to be what now? mv squared over r plus mg. mv squared over r plus mg. These are the bottom, the force at that point that will provide the centripetal force will be what? mv squared over r plus mg. Please take note. Okay, this is all about this aspect. This is all about this aspect of this discussion. And we are going to now consider calculation in this aspect. We are going to consider calculation in this aspect. We are going to apply these forces we are going to determine so far at the middle, at the top, and at the bottom. We are going to use them to calculate in our subsequent teaching. Okay, thank you very much for staying with me on this platform. All the best. All the best.